Hello, in this discussion we will be talking about determining the signs of a trig functions of any angle in any given quadrant. So this is kind of helpful because sometimes when you take one of the trig functions at an angle that ends up in a specific quadrant, it's kind of useful if you knew if it's positive or negative to begin with. And that's what this one's going to concern us with. So if you look at an angle that's in the second quadrant, AB, R, okay, remember that on a previous video. If we take the sine of theta, that's going to be B over R. It's going to be positive. Why? Because B is positive because A is negative and B is positive in the second quadrant. Okay. Think of any ordered pair in the second quadrant. The abscissa will be negative and the ordinate will be positive. So both the B and the R are both positive in this quadrant. So sine of theta is positive in this quadrant. What about cosine? Well, cosine is A over R. A is negative because you have to go left then up. So A is negative and R is positive. You're like, why is R positive? Well, R is a distance from the origin to the point AB. As a matter of fact, R is equals to the square root of A squared plus B squared by the Pythagorean theorem. So you can actually figure that out based on what A and B are. But at the end of the day, R is a distance. So therefore must be positive. Now the tangent of theta is the B coordinate over the A. So it'd be like opposite over adjacent, B over A. But since B is positive and A is negative, the ratio B over A will be negative because a positive divided by a negative is negative. So the tangent of theta is B over A. And that's less than 0. So therefore the reciprocals, cosecant of theta is R over B, and that's positive. Secant of theta is R over A, which is less than 0 because A is negative. And the cotangent of theta is A over B, and that's negative because, again, A is negative and B is positive. So looking at these one right here, only the sine and the cosecant are positive. But think about this a little bit. What if the terminal angle ended up in the third quadrant? Okay? Now, in the third quadrant, they're both negative. A is because you go left then down. So they're both negative. If A and B are both negative, what happens? Well, the sine is going to be negative in this quadrant because if it's in the third quadrant, because it'll be B over R. And if it's in the third quadrant, B is negative. So it's going to make the sine of theta negative in the third quadrant. Same thing with the cosine of theta. Cosine of theta would be the A coordinate over the R. So in the third quadrant, A is negative there as well. So cosine will be negative in that quadrant. But look at tangent. Tangent of theta is the B over A. And if B and A are both negative, what's a negative divided by a negative? That's positive. So tangent in the third quadrant is positive. So based on which quadrant you're in, these trig functions have specific signs. Our next table on the next slide is going to summarize that for us. If you're in quadrant 1, 2, well, if you're in quadrant 1, they're all positive. Notice the first row, positive, positive, positive. So the sine and the cosecant are positive, the cosine and the secant are positive, the tangent and the cotangent are positive. Why is that? Because if the terminal side is in the first quadrant, the A is positive, the B is positive, and the R is always positive. So taking any ratios between the A's, the B's, and the R's, and they're all positive to begin with, is going to make all the ratios positive. That's why all 6 trig functions are positive in the first quadrant. Because there are no abscissas or ordinates that are negative. Okay? Now, what about in the second quadrant? We talked about that a second ago. Sine and cosecant were the positive ones, and the other two are negative. We also talked about the ones that are in the third quadrant. The tangent was positive because both the x-coordinate and the y-coordinate, in other words, A and the B, are both negative. So that's going to make the sine and cosecant negative. That's going to make the cosine and the secant negative in the third quadrant, but it's going to make it positive for the tangent. Okay? And in the fourth quadrant, the abscissa is positive, but the ordinate, the B, is negative. So that makes the cosine going to be positive, but the sine and the cosecant negative, and the tangent and the cotangent negative. So we make a little chart here, okay? So in the first quadrant, the A and the B, the coordinates are all positive. So all 6 trig functions are positive. In the second quadrant, the sine is positive and the cosecant is positive. All others are negative. And then the tangent and the cotangent are positive in the third quadrant, and all others are negative. And in the fourth quadrant, the cosine and the secant are positive, and all others are negative. And this little right side kind of gives you a little summary using some little symbols. Sine and cosecant positive in the first and second quadrant. The cosine and the secant are positive in the first and fourth quadrant. And the tangent and the cotangent are positive in the first and third quadrants. Now there's a way to remember this. There's a lot of ways to remember this. People memorize this by starting in the first quadrant and go counterclockwise, where it says all positive. Take the word A for all. And then on the second quadrant, sine, that's S. And the third quadrant, take T for tangent. And then the fourth quadrant takes C for cosine. So you got A, S, T, C, starting in the first quadrant and going counterclockwise. A, S, T, C. All students take calculus. So A is for all positive, students is for the sine, and then take is for tangent, and calculus is for cosine. It's a little mnemonic device that people like, and they remember what the signs are. So I like that little right side margin, these little with the symbols, plus for the sine, and then plus for the cosine in the first and fourth quadrant, and then the tangent and the cotangent is the first and third. So, but some people just remember the ASTC, all students take calculus, and then they're good. So this just depends on the individual. So got another example here. All right, we're going to find the quadrant in which the angle lies. So if sine of theta is positive and cosine of theta is negative, name the quadrants in which the angle lies. So which quadrants did you remember that the sine of theta was greater than 0? Remember, all students take calculus. Sine is positive in the first and second quadrant. Cosine is negative where? In the second and third quadrants, because it's positive in the first and fourth. So when they say cosine of theta is less than 0, they're saying cosine of theta is negative. Less than 0 means negative. So we got sine of theta greater than 0. That means it's positive. So that's first and second. And then the cosine of theta is negative in the second and third quadrants. So which quadrant must you be in? Where is theta going to be at? Well, it's one that's being picked twice. And the ones that are being picked twice is the second quadrant, because that's the quadrant that the sine is positive, although it's positive in the first quadrant too. And that's also the quadrant where the cosine is negative, even though it's negative in the third quadrant as well. But these are the ones that are in common. So we're in the second quadrant. So that tells us where theta is, which becomes quite useful. You have any questions on this, you let me know, and you have a good day.